Hey folks, welcome back to Elm Town. I'm your host, Jared Smith. We'll be visiting with Dwayne Crooks today. But first, let me talk about our sponsor. Logistically is the company where I work. At Logistically, we make transportation management software for third-party logistics companies and shippers. I'm grateful that Logistically pays me to spend a bit of my time recording Elm Town episodes, as well as pays for our recurring production and hosting costs. We build the front end for all new features in Elm. I just looked, we have over 100,000 lines of Elm code in production. We're eager to talk to folks who enjoy writing Elm. Please drop us a line, elmtown@logisticallyinc.com. I'll put a link in the show notes. So, introducing Dwayne Crooks now. His community contributions include maintaining the Built with Elm website, recently published package Elm Natural, the 2048 game in Elm, and that's just a few of them. Let's get into it. Dwayne, welcome to
Hey,
Elm Town.
hi Jared. Thanks for having me. So I'm from the beautiful Caribbean island called Trinidad and Tobago, and I've been programming for quite some time now. I've been doing it professionally for almost 12 years as a web developer, and I currently maintain the Built with Elm website, as well as I wrote the Elm 2048 clone that you guys might have seen recently.
Yeah, it's beautiful. When you were starting out in programming, what was that like? Would you tell us, maybe go back a little bit and tell us about how you became interested in programming or knew that that's what you wanted to do?
Yeah, sure. So when I was young, I was interested in playing video games, as we probably all were, and I enjoyed playing like fighting games and sports games and stuff like that. And so when I got my first computer, I wanted to build a Street Fighter-like game, and so I taught myself C and something called the Allegro game programming library, and I attempted to build it, but I realized that I wouldn't be able to complete it because I needed more skills besides programming skills, and I really didn't want to learn those extra skills like the graphic design stuff and song production stuff. But I was interested in solving problems and designing algorithms, and I discovered that the best place to do that was in something called algorithmic programming competitions. So I would train on USACO problems. USACO stands for United States of America Computing Olympiad. So they had like a training area where you can go and train on these problems to get better, and then I'd compete in top Qoda competitions. And so that was where I got into programming and got a love for it. And from there, it led me into university where I studied math and computer science. And yeah, so that was the start of my love for programming, I'd say.
Oh, neat. Okay, so this, you said USACA program. Did I say that correctly?
USACO.
Okay, USACO.
Yeah.
Okay. And that, around what age were you when you were doing that?
I'd guess it was probably around the age of 15, 16, somewhere there.
Okay.
Yeah.
So you were programming for a couple of years, and then when did you go? At this point, I'm guessing before you went to college. Is that correct? Went to the
hmm
university.
hmm
Okay.
So I was programming in secondary school, which is
Mhm.
the equivalent of high school in the States. And I studied something called information technology there. And so I was programming all throughout high school. For my final year project, for example, I wrote a music program in Pascal. So you can, like, there was a staff on the screen, and you can put your notes onto the staff, and you can play a tune on it. And so to build that, so it was in Pascal, and it was a MS-DOS program, and it was interesting. I learned like a lot of neat data structures and stuff to get that built.
Oh, cool. Yeah. So did you have to learn about some music theory as well, or was it simple enough that there wasn't much to learn there, or did you already know those things?
No, I didn't know those things, but I didn't have to learn anything about music theory to build it. It was simple enough uh, to build without that knowledge.
Okay, yeah, so that's good. You could focus on the algorithms, the part that you love, right?
Yes, yeah.
Yeah. Excellent. Excellent. So you've been programming professionally for about 12 years. Before that,
hmm
you were at the university and you'd completed this USACO program before that. At what point did you discover Elm?
Sure. So it was in one of my previous jobs where I was working on a large React code base, and this code base was becoming a nightmare to maintain. And so I was actually on the lookout for something that would help me improve the solution that we had. And I think I stumbled upon it via maybe I'd say a Hacker News post. I don't know for sure, but yeah, I'd say a Hacker News post, and I read about it, and it seemed interesting, and so I decided to try it out on a couple of side projects, and that went well. And so I tried it out on a small feature that we had in work that that I thought could use some refactoring. And so I tried it out there. And when I built the solution, it went from like having 10 plus files to just this one Elm file that was like well structured, and it was easy to reason about the code and everything like that. And so that impressed me a lot. And so and so that's it. That was my first encounter with Elm.
Okay. Yeah. And so this React code base, you said that the problem you're trying to solve with that was the maintainability of a large code base. Is that
Yeah,
correct?
yeah.
Yeah.
Um,
So
so just to add to that, so before that, so I was like doing programming competitions and I was like writing small applications. So maintainability was never really an issue. But it was at this company where I worked there for a little more than 5 years. And, as time progressed, we have to make changes to the code, and changes were progressively getting difficult. And so I was just looking for um, to make my life easier.
yeah, of course. Yeah, that sounds familiar to my journey as well. I was looking for something that was more maintainable, but also I was really looking for the quality. I was working in healthcare, and the reliability of Elm just sounded like something that would be really useful in my domain. But yeah, maintainability is huge, and of course
hmm
the ability to refactor so seamlessly with Elm is unbeatable in my opinion. But it's
Yeah,
biased, so
definitely.
so then you put this little piece of Elm in this large code base. What happens then?
Yeah, so I open a PR and I tell I did it like on the side. I didn't tell anybody that I was doing it. I just wanted to convince myself that, this what could be a viable solution. And then I
Hmm?
opened this PR and I shared it with my teammates, and they liked it. But unfortunately, like even though my CTO saw the benefit that it brought, it wasn't ultimately merged into the code base for a variety of reasons. We recently moved our code base from like using ES6 and a Backbone JS style application over to React, and started using ES 2016 and stuff like that. And we moved from CoffeeScript. So it was like we were already in a transition phase. And then to come and ask to have Elm, this new style of programming language and this new way of thinking about the problem solving, it was like might have been a burden on the team. And so ultimately we didn't include it in the code base. But that experience that I had with Elm really made me want to get like better at Elm and be a better advocate for Elm.
Oh yeah, so for you it was a win either way. But I
Yeah.
understand that position of being in where it's it's a lot, right? There's a lot going on already. So
hmm
to try to introduce anything new, no matter what, it's it's just you're already transitioning. That makes a lot
Yep.
of sense.
Yep.
When you had found Elm at this point, did you previously have experience with functional programming?
Yes, I did actually. So at university, although we never studied functional programming, there was a professor who I spoke with, and he actually put me onto functional programming. He referred me to like a few books on the topic, and one of them was SICP actually. And so my first introduction to functional programming was through SICP.
Okay, cool. And I'm not. I've heard of that book, but I haven't read it. I don't know the details. Could you tell us a little bit more about it? What language is used in there?
Sure. So SICP stands for the Structure and Interpretation of Computer Programs. And it was this famous book written by Gerald Sussman and Harold Abelson in, I want to say, in the early 1980s. And it was used in like the introduction computer science course at MIT. So it's famously known as a hard book, as a difficult book to get through, but it does have like a lot of great concepts in it. And so it's written. The concepts are explained through the scheme programming language, and like the first chapter is like a masterclass on functional programming. It teaches you about higher order functions, like map, filter, fold, etc. And it about first class functions, like having functions as data structures, being able to pass functions to other functions or to return functions, and it gives you this a good foundation in that style of programming. So it was a good introduction.
Okay. Yeah, that sounds like you would really have a lot of knowledge that, like, for example, myself, when I was starting with Elm, I did not have experience with functional programming. I had tons of object oriented programming experience. I had not read any books at the university. We learned Java. So, it was all OOP all the way down,
Hmm.
But the way that Elm taught me functional programming, the guides and the people in the community who were putting out blog posts and recording videos,
Hmm.
explained it in such a way that I didn't have to know a lot of that. I mean, I sought it out in a
Hmm.
bit of a way of, what is this thing, what's really going on here. But I never had to learn about things like, the M word monad or,
Hmm.
any of those types of things. So were those concepts that you learned through that book? Those terminology, is that part of it?
I'd say some of the concepts I learned through that book. Monads isn't talked about in that book, so I didn't learn it there. I'd also like experiment on the side with new languages from time to time, and so I did experiment with Haskell and was introduced to monads through there. It was for me as well a difficult concept to understand at first, because it's usually presented through a lot of examples in a lot of ways, and it can become confusing. But yeah, so through experimentation, yeah, I would like through experimenting with other languages, I would learn other concepts as well.
Okay. All right. Well, I want to talk about your transition now because you said this company where you had introduced Elm into the React code base, or you had experimented with it,
Hmm.
was at a previous company. So could you tell me a little bit about what happened after you'd done that, after you had started experimenting with Elm on the side, working with it more in your own free time? How did you go? Where did you go from there?
Sure. So after being rejected at that company with trying to introduce Elm. I stayed there for a little while longer, but then I ultimately left there. And in the interim, I decided to do more of a deep dive on Elm to learn it better. And so I do like little side projects to get familiar with it. One of the things that I did was so there's Free Code Camp, and they have this curriculum that teaches you JavaScript. And at the end of the curriculum, they give you like 5 projects to do to test your skills. And so I decided that I would do those 5 projects in Elm to see if I really understand the language and if I can actually build a UI in it. And so I did that. And then I came up with a few other projects that are due to test various ideas that I had to ensure that I can work with it better. And then, how far do you want me to go along with?
Well, as deep as you would like. We have time, so yeah, let's get into it. Tell me more.
Sure. So yeah, so after completing those 5 projects, which were like a random quote machine, markdown previewer, something called a drum machine, and a calculator. So they all allowed me to experiment with different ideas that I had. I wanted to understand more how to build reusable views. I read Evan's code on the Elm sortable table, and that inspired me to try to build a reusable view, and that is what became something called Elm Rater. Elm Rater is like a star rating widget that you can customize in any way you like to to add as like as a component to your project, as a widget to your project. And so that helped me understand how to build reusable views a little better. And then I also wanted to learn how to separate like the business logic from the user interface. And so in order to do that, I tried to build a small tic-tac-toe game and Elm 2048. So the initial version of Elm 2048 didn't have animations at that point, but it was one of the projects that helped me understand how to separate the business logic from the UI, because I didn't want I wanted to be able to easily test the code without having to go through the user interface, and
Okay,
that
yeah,
yeah.
the Elm 2048 game that you made with the animations is just incredible. I love playing that. I wanted to ask you, throughout that building that game, what were the obstacles that you faced when you were creating it?
Sure. Well, the major obstacle I faced was actually getting the animation. So my goal at the start of the project was, how do I separate the business logic, or the game logic in this case, from the user interface? I wanted a clean separation. And with animations, it it seemed as though if I introduced it, or the first time I tried it, when I was introducing it, it like it caused an entanglement that made it hard to test the program and to understand the program. So like it was getting in the way. So this process happened over a period of time. And then I realized that maybe I can return a value from the business logic side that describes what happens when you move the grid, so that the UI side can interpret that value and then display what needs to happen. So I figured out that I needed to give the grid a little bit more structure so that the UI side could interpret that structure. I can go into more detail as to how like what that structure is and how it works if you want.
Sure, yeah, I guess to kind of reiterate, make sure I understand, your original goal was to cleanly separate the business logic of the game from the UI of it.
Yeah.
And the part where you struggled was the animation. That was the challenge that you faced, where they were becoming entangled with the UI, and so you felt like maybe at that point you did not have that clean separation that you had hoped for. Okay,
Yeah.
and so you created some structure that allowed you to create a better separation. Yeah, let's talk. You don't have to get too much into detail as far as trying to describe code. I think Dylan Kearns and Jeroen Engels on Elm Radio do such a great job of describing code, but for me, I'm not so good, so so good at that. So yeah, but if you do have a way of describing it that comes to mind, let's go for it.
Sure. So I'll take it from a high level. I don't necessarily need to describe the code, but I'll like describe what happens at a high level. So I was able to come up with this grid structure. So let's think in 2048 there's a 4 by 4 grid. Let's just reduce it down to a 1 by 4 grid. So one row. And I'd go through like 3 scenarios to explain what happens. So in the first scenario, let's suppose in this 1 by 4 grid, we have a tile, which is the tile with a number 2 on it, and we want to move it to the right. So it's at the far left, and we want to move it to the right.
Okay.
Well, in
And
this
just
case,
to the goal of this game is to combine tiles that have the same numbers, and
yes,
so they add together, and then you keep combining those. So you add 2 and 2 make 4, and then you add another 2 and 2 to make 4 again, and then you can combine those two fours to make 8. The goal of the game is to keep adding those numbers up until you get to 2048.
yes, exactly. Yeah. So in this scenario, if we move the tile across to the far right, like there's no issue there. The animation is simply to move the tile. Um, but there are other ways the tile could interact with other tiles. So the structure of the grid is such that their tiles could be in various states. So it can be a new tile, it could be a composite tile, or a merged tile, or an old tile. New tiles are tiles that get added after a successful move. Composite tiles are these tiles that get merged. So in the first case, we didn't have 2 was a new tile. It didn't merge with anything, and so when it moved across, it became an old tile, essentially. The next scenario is, let's suppose we have 2 tiles, a 2 and a 4 on the far left, and then we want to move it to the right. Well, it's 2 and a 4, there's nothing else, so there's no merges happening. And so again, this is a scenario where the 2 and the 4 just slide across, and it becomes an old tile. But it becomes an old tile with there's a structure within there that tells you where the tiles moved from, so that when I return it to the UI, I'd say these tiles were at, so for example, 2 was at position 1, 1, and 4 was at position 1, 2, and these tiles moved to position, the 2 tile moved to position 3, 4, and the 4 tile moved to position 4, 4. And that's it. And so when the UI sees that information, it knows that this is a move to instruction, if you will, and it does an animation to move those tiles. The final scenario, which is where the complication comes in, is, say we have 2 tiles, a 2 and a 2, and it's on the far left, and we want to move it to the far right. Well, when it moves to the far right, it is supposed to combine with the 2s are supposed to combine to become 4, and that 4 is supposed to dissolve into the screen, and the 2s are supposed to dissolve into the screen, and the 4 pops back out, and then you have the 4 tile. So how the structure looks in that case is that, well, we have 2, 2 being old, it moves across the screen. Both become merged tiles, and the merge state has information that says these tiles moved from 1, 1 and 1, 2 to 4, 4. Both of them move to 4, 4. And it also adds a new tile called a composite tile, which is the 4. And so when I return that value to the user interface, it can interpret the merge and the composite and say, well, let's first move these 2 tiles across the screen, dissolve them, and then pop out the composite tile. And all this stuff has to live in the DOM because of how the values need the DOM structures need to be there in the DOM so that the DOM can do the animation correctly. Yeah.
Right. Yeah, I've experienced that before too. You need the previous state in order for it
Yes.
to calculate how to get to the next state.
Yes.
Yeah, that makes sense. And you explained that really well. Thank you. I think that the result of all your hard work on that is great. It's just such it's so enjoyable to complete those, to do those merges when you see them come together and the colors change, and so that came out really well. It's so fluid, and so thank you for putting all the work into making that. I've been playing it a lot recently as we've prepared for this.
Yeah, yeah, that's great to hear. I was addicted to the game when it first came out, so that's why I had such interest in it, and like it was really paining me that I couldn't figure out how to get the animations done. So I was happy when I finally figured it out, and like I appreciate all the good feedback that I got about it as well.
Good, yeah. And so at that point, then you felt like you had solved that puzzle, right? You
Hmm.
had found out how to really separate the business logic from the UI. And so, did you feel like then it was testable? Did you add tests for it, or how, what? How did you really know at that point you would succeeded just by looking at the code and working with it, or what?
Yeah, I did write a few tests for it, but I didn't go overboard with the tests. But yeah, based on the structure of the code, I knew I accomplished what I wanted to accomplish. I was able to like instantiate the game logic outside of whatever UI it was and test it out manually. But I didn't write automated tests, like much automated tests for it. But yeah.
Sure, yeah. So I had worked on a game at one point, 3D pool game with Andre Kuzmin.
Hmm.
And when I had approached him with this idea, this was kind of my goal. I was like, okay, I don't know much about doing 3D. And he had at that point done a little demo of some pool or billiard balls, rolling around on the table. But I have a lot of experience playing pool. I
Hmm.
played in a league, an amateur league, for a while, and so I understood the rules. And I thought, if we could separate this so that he worked on the part that displayed and and calculated all of the 3D, all the hard stuff, right, in
Hmm.
my eyes, and then I could just focus on the business logic, of playing pool, which I was like,
Hmm.
oh, okay, this is the easy stuff. Then I could figure out, how to be productive in this in building this game, and it turned out really well. I wrote a blog post about it, so I won't go into too much detail here.
Hmm.
This isn't what it's about, but just that concept of being able to separate business logic and UI works really well when you find out, when you kind of tune it and get your data structures just right. I
Yes.
agree. We had just one little bit of detail on it where we would run this calculation that required no knowledge of 3D logic. It wouldn't even have to be a 3D rendering of the pool game. All you need to know was what state the balls were in when you started, and then it would calculate and say what are the possible next states, or what next state is it in,
Hmm.
and return that. And so that worked out really well, and I was able to write unit tests for that without even having to go through the UI. So it sounds like it's a similar process of just figuring out how to get that structure right so that you can have that information in data form.
Yes. Yes.
Yeah, excellent. All right, so you were building these games, and you were really getting deep into understanding how Elm works, how to structure programs in a nice way, and then you're still working at this place you've been working at, correct? At this point, or had you already moved on, or
I
where were
already
you?
moved on. So the Elm 20 the 2048 game a more recent is a more recent project that I completed. So I built the first version of it without animations a long time ago, but the discovery of how to do it with animations is more recent. So we like kind of skipped across like a few things. So at this point, at my current company, I'm Real Folk, and I'm actually doing Elm in production. And so that's when the realization how to add the animations to 2048 comes in. But there's like some stuff before that we could probably go back to.
Yeah, sure. Uh, what happens in between there? You know, you build this first version of 2048, and then some things happen, and you you build another version. Let's get into those details if you want to.
Yeah, sure. So so after learning as much as I can learn building, I'd say like one-page applications without any routing and stuff like that. I wanted to try to build applications that did include routing. So I looked for tutorials. These tutorials were in like other frameworks like React and Ember JS and stuff like that. And so I built something called Super Rentals, which is a tutorial from the Ember.js community that goes through and shows you how to build this web application that has routing and some other stuff. And after building these like toy projects, I decided that maybe I can use my skills to work and to contribute to something. And so I looked around to see what was there, and I saw that it was built with Elm, and it wasn't being actively maintained. Like I saw that there were some issues opened, and also people had PRs open for some of the issues as well, but no activity was happening. So I decided to reach out on Slack with the current maintainer, and I told them like I wanted to make a contribution to the project, but I saw that like there was no activity going on, and like what's the process to contribute. And I got no response, but after a few weeks, Evan actually reached out to me, and he told me like he would come out with a plan for my changes to be added if I actually go ahead and do what I say I plan to do. And so I went back and I made the changes and reached out to Evan again, and he coordinated with Luke Westby. So Luke Westby is actually the original creator of the Built with Elm project, and he owned the domain and rights to like make merges to the code and stuff like that. And so he reached out to him and told him that I wanted to contribute, and they decided that the best course of action was to actually give me like full access to the project, like make me become an owner on the project, because they liked the contributions that I was making, and I was enthusiastic about like trying to maintain it, and so they gave me ownership of the project, and it went from there. I made more changes. I added I added some projects that they had submissions, but they weren't added to the project as yet, and then I announced it on Discourse, and it went from there.
Yeah, thank you so much for maintaining Built with Elm, and that's I think a huge contribution to the
Mhm.
community. So you're still maintaining Built with Elm, is that correct?
Yeah, I'm still actively maintaining it, though I'm not
Okay.
actively asking for submissions or going out and getting submissions, but I'm ensuring that the code base is up, and that when submissions do come in, that they're added promptly. A friend expressed interest in doing a redesign of the site, so I'm excited for that uh, to see to build that and to contribute that to the project. So we'll see.
Oh yeah, that sounds exciting too.
Mhm.
Well, yeah, I think that it's a project that I'm glad we can talk about because I would like um, more things to see on there.
Mhm.
I'm really every time I go to it, I look and see what's new from the last time. Um, so yeah, if there were a redesign, that would be pretty cool too.
Yeah.
All right, so at this point, you are becoming more and more involved in the Elm community. You mentioned that you are now an engineer at Real Folk. Do you want to tell us a little bit about that, about how you came to work there and what you do there?
Sure. So after the time I spent at that the company where I tried to introduce Elm, I left there and I was unemployed for a while, and that's when I did like a lot of stuff related to Elm and learned a lot and built complete projects. So I was able to use like all that work that I did, built with Elm and all that stuff, as examples of stuff, things that I can do with Elm, and that landed me a job at Real Folk. So Real Folk is a small consultancy, and they mostly work with they mostly work with government clients. Dhruv Dang is actually the CEO of the company. I think he was a host on the podcast previously, and he's really he's really good at designs, and so he makes these interesting designs, and we build them in Elm.
Yeah, so I happened to reach out to Dhruv. I know you gave me his contact information, but he had a question or a situation that I could ask you about. So, what that was is he mentioned that you were working on this project where you used a JSON alternative for sending data over the wire in
Mm-hmm.
a Lisp-like syntax, and this was called modern, MDRN,
Mm-hmm.
modern. And here's a little bit of a quote from him, and then I'll kind of let you pick up from there.
Sure.
He says, both the Elm and Haskell parsers were working well until we noticed a strange performance bug where certain payloads were very slow to parse. Dwayne was tasked with finding the root cause and implementing a fix. What do you think? Is that something that you remember?
Yeah, I do. I do remember it. It was one of the more interesting things that I worked on at Real Folk. So Modern is this experimental project. It's a lot of things, but one of the things that it represents is a data interchange format, and that format is Lisp-like. So it has a lot of parens, and we use that to structure our data and then send it across the wire. And so our backend was in Haskell, our front end was in Elm, and so both sides needed to be able to pass this data structure. The problem appeared on one of our article pages. So the website is actually still up. So if you go to the Real Folk website and you go to the blog and you try to open one of the articles, you can open the DevTools and look at the network tab, and you'd see a request being made to an API endpoint. And what's returned is this Lisp data structure, and it's a really long, large Lisp data structure. So the page was taking like insanely long to load. It's like on the order of minutes, and we couldn't understand why that was happening. So I did some debugging and identified that it was the modern parser that was the source of the issue. Uh,
That
the
is a long time. Wow. Yeah. You said minutes that it was taking to parse it?
Yes, yes,
Well,
minutes.
that makes it clear, though, right? At least
It
it's not one of
does.
those Heisenbugs, you know? It's somewhere in the parser. Okay. So
Yeah.
what did you do then?
So I investigated. I looked into the parser and I saw that it like contained many uses of backtrackable, and so I knew that could be a source of the performance degradation. There wasn't any context-free grammar for the site. So typically, when people are building parsers with parser combinators, they rarely write context-free grammars. But I like to have the context-free grammar around as an artifact to understand like what the language is supposed to be, even though it's so easy to write parser combinators. And so I backed out of the parser a context-free grammar, and that helped me see that there was like a production of the form. So there's data, and it can either go to a list or something called a map reference. And a map reference could either be a symbol followed by a dot followed by another map reference, or a list followed by a dot followed by a map reference. So it means then that the list could be optionally followed by a dot and a map reference. And so that and when you looked at the code, you saw that that was exactly where backtrackable was used. And so backtrackable was actually used on the map reference production. So what that means is that it would try to parse a list, then a dot, and then a map reference. And if that fails, then it would try to parse the list. So it means if you have a long list but no map reference, so no dot map reference, you'd be parsing that multiple times. And so I developed some test cases of various sizes that just contain these list structures but no map references of, of various sizes 10, 20, 30, etc., constant increments. And when you would run the benchmarks on it, you'd see that the timing increased by a constant factor. So it showed that the algorithm that we were using was exponential. And so that was why it was taking like on the order of minutes to process that. But there's a easy solution to the problem, like when looking at the grammar. So the issue is that there's this common prefix on the production, and you can use a technique called left factoring the grammar to remove that common prefix, and you won't have. And when implementing the grammar using a parser combinator, you don't have to use backtrackable there. So to give a simple example is if you have a production that goes from A to B alpha or B alpha 1 or B alpha 2 or B alpha 3, the common prefix is B, and so you can rewrite the grammar to get A going to B capital A prime, and now this A prime goes to alpha 1, alpha 2, alpha 3, and so that removes the common prefix. And when you're implementing the parser combinator, you don't need to use backtrackable to work with it. So I did that, and then I re-implemented the parser, and the the test cases went from on the order of minutes and seconds to microseconds, and then put it on the page, and the page load very quickly.
Wow, excellent. So you mentioned a few terms here that folks might not be familiar with. You mentioned parser combinators and context free. Could you describe maybe in some other terms what those things mean?
Sure. So I'd start with grammars. Grammars describe languages, and so you write a grammar to specify the sets of strings that you want to represent in your language. So if you're talking programming languages, the grammars just specify what the syntax of that language would be. And for the computer to be able to recognize your language when it's parsing the syntax of your language, you can write something called a recursive descent parser. So you take your production, and for each production, you write a function that parses that part of the grammar. And long ago, people came up with the idea of abstracting that recursive descent parser using higher order functions. And so now parser combinators are a means of implementing a recursive descent parser, but using function composition.
Excellent. Yeah, thank you. That makes more sense. And so the reason that you were doing this is because this was a syntax, this data interchange modern that you're using was not something that already had an implementation in the language, right? It's not like JSON where folks would be familiar and already have a set of tools that work with that and understand the syntax.
Yes.
That makes sense. That's a pretty interesting problem, and this was one that I guess you all created this syntax, the modern. Is that something that you had discovered or something that your team built, the syntax modern?
Sure. Yeah. So modern is actually the brainchild of Dhruv. He created it. So it was there before I got there. The data format itself is supposed to allow you, or to be easier to parse data between backend and front end. One of the nice features it has like good support for numbers, for large numbers, and for rational numbers and all that. So you can parse your numbers precisely between backend and front end without losing information. I think he also wrote a binary representation of the format as well. And so it's supposed to allow you to use smaller payloads when sending your data across.
Okay. Yeah, that makes sense. And because I have a little bit of knowledge about some of the projects that you all work on, I know why having being able to represent large numbers would be important. But could you describe kind of what projects might have led to using a syntax like modern, where you would be able to do that?
Sure. So the project itself is experimental. So they like these were ideas that Dhruv was experimenting with um, for for over a year. I don't think there was any concrete project that he ever used it on, but I know in the past there would have been projects that would have benefited from having that ability. And so it was something he wanted to explore. I know, for example, when I was working on a point of sale application, and we would pass JSON across the wire, we had to represent it as strings, or if we were passing floating point values across, when you pass the floating point number across, there's a possibility for the loss of precision and stuff like that. And so in that case, it would have been nice to have a format where you can just represent the number precisely and send it to the client. So there's nothing concrete that that we ever used it on, but it was like a thought experiment to see like if this would be useful, make sense, and like how we would go about it.
Okay. And so I may be making an assumption here, but you all work on a project called Qoda, and my thought was that this data interchange format would be useful for that project. Is that so, or do you use it on that or not?
Yeah, we do work on a project called Qoda. And so just to give some context as to what Qoda is, it's a decentralized application that allows you to use the blockchain to do borrowing and lending. You can borrow and lend at a fixed interest rate for a fixed period of time, and you can borrow and lend any types of alternative cryptocurrencies that you want. So yes, it does make sense that we'd use it on that, but what unfortunately, due to like the requirements of the project and the time constraints that we had, we didn't, because since modern is experimental, we didn't want to use that. It wasn't like production ready as yet. So that's why we tried it out on the RealFolk website, which is fine, and we tried it out on a few other small projects, which is fine, but we didn't want to try it out on Qoda as yet, because of time constraints and stuff like that. So it's not used there.
Okay.
Yeah.
Well, yeah, that's what happens when I make an assumption. So, what format do you use? Uh, how do you talk with? I know it's decentralized, so I guess not with a server or in a single
Mhm.
server, but how do you talk with whatever you need to talk with?
Yeah. Yeah, that's a good question. So Coda is built on the Moonbeam network. So to keep things short, it's an Ethereum compatible network. So if most people would have heard of Ethereum as opposed to Moonbeam, but it's Ethereum compatible, which means that the APIs to access the blockchain are similar. And so the way we communicate with the blockchain is through a JavaScript framework called ethers.js. And our Elm application communicates the ethers.js over ports, and ethers.js interacts with a wallet called MetaMask and the with the Moonbeam network. There is a backend, very small backend to cache data that is written in Haskell, and for that we use JSON to send the data across, but it's like very minimal in its usage of the backend.
Sure. Okay. So you're using Moonbeam, which is built on Ethereum. And Moonbeam, is that something that is built by you all, by real folk, or is that something that you've uh, borrowed, that you're using, that someone else built?
Yeah, so Moonbeam it's not based on Ethereum, it's a separate network, but the API that it exposes is similar to the API that gets exposed on the Ethereum network. Moonbeam is a separate project built by blockchain developers in a different ecosystem. So we have nothing really to do with Moonbeam, but external parties can build applications that use the network. And so we're one of those external applications using the network.
Okay. Interesting. Yeah, this is a world that is pretty much unknown to me, so I may be asking weird questions. So please excuse me
Yeah, no worries
as
because
we go
I,
down
I
this
just
route.
recently got into blockchain development as well.
Okay.
So yeah.
Yeah. So uh, speaking of how you interact with this using the Ethers.js JavaScript library, you
hmm
recently posted on Discourse about how you uh, do use ports. Would you, of course, we can put a link in the show notes about that, but would you tell us a little bit about how that's working out for you?
You sure? So the way it works in the blockchain ecosystem is that the blockchain is supposed to be the source of truth. So it stores the data. It's supposed to be the one that handles the business logic. And so you write that business logic using smart contracts and stuff like that. And to interact with the smart contracts, we need to use ethers JS. So the smart contract has like all the business logic in it. So it has a lot of functions that you need to call in order to process that data and to work with the blockchain. Our user interface is is just a user interface, and it needs to just coordinate the actions of the user to call the appropriate functions in the smart contract so the writing gets done on the blockchain. So in order to if we were to write it in a naive way, it means that every interaction that the user makes, we would need to have one port for that interaction. And so we'd end up with 200 plus ports because there's a lot of variation in the interactions and there's a lot of functions that we do need to call. And it's all happening on the JavaScript side. And Evan wrote a long time ago in the Elm guide as a suggestion that two ports is at most two ports is all you need. So I decided to take that to heed that advice and try it out and just describe the messages that we want to pass over the ports instead, right? So over the port we just describe the function that we want to call. So we describe the function signature. This is the function. This is the data that we want to pass as arguments, and we pass that through the ports. So we just have two ports. We have one port to send information from Elm to JavaScript, and one port to receive whatever data that we want to receive. It's not a synchronous process. We just send the data and we don't really care what we get back, but when we get back data, we know how to deal with it. And so it's just we send messages through those ports. Stuff happens on the blockchain, and we get data back, and it does stuff in the UI.
Yeah, and so the benefit of reducing the number of JavaScript calls is you have this one place where you know any interaction, any interop with JavaScript
Yes.
is coming through there. Yeah, I like that approach as well. And so it ultimately goes through this single port module. Do you do anything to make that interaction nicer on the Elm side so that each time you call it, maybe you have a data type that then will convert from that standard in Elm to the JSON that you would encode to be passed across the port, anything like that?
Yes. So every interaction between Elm and JavaScript is abstracted as a separate module. And so that module handles like what the message would be, how to decode that message, how to encode the message, and whatever other data structures that we need to properly represent that data. So we can just look in one directory and see all the possible interactions we can have with the JavaScript side.
Nice. Yeah. Yeah, we follow a similar pattern too. I'm glad that you shared that. I've been thinking about sharing that process that we use as well, but you've beat me to it. So I appreciate you taking the time to do that. I think it's really helpful because a lot of folks seem to get kind of hung up on how to do that JavaScript interaction and kind of make a big deal about what it is. But I found it to be pretty nice. So I think when you structure it in such a way that you're not kind of scrambling around to figure out where the interactions occur, and you have nice APIs built around that in these kind of modules that we've done, like it'd be port slash, module name for each of the different interactions, but it then calls the port, the standard ports module to actually make the call, then it works out really well. So yeah, that's really cool.
It's really nice how that worked out because I never had to use ports and to that extent before. And like in the Elm community, or when people first get introduced to Elm and you tell them that the JavaScript interrupt is such that you have to use this new idea called ports, like people get to dislike Elm a little bit for that, and they think that it's restricting them. But up to this point, we have had no restrictions with regards to ports. And so it was nice to see that it was an elegant solution.
Yeah, thank you for saying that. I think you're right. I think the thing that sometimes people think is, well, how do I use, library XYZ from the JavaScript ecosystem in Elm if I can't directly talk to it, right? There's no direct FFI or foreign function interface to it. And so if you're kind of tied into that particular library that you're using, you may think, oh, well, I cannot use it, right? But you can still use those libraries. You just have to think a little bit differently about it, right? Because everything that goes into JavaScript land, we have to assume may never come back, right? Because, it could fail. There could be side effects. You can make a request for something and never get anything back. So you just structure it in that way of sending messages out and maybe, giving a return address if you're expecting something back. And when you kind of change your mind to think about it in that way, the same way you would think about making an HTTP request, then I think it kind of, for me anyway, it clicked, and I thought, oh, okay, now I can just consider it to be the same way I would do any other command, and go through the Elm runtime, the Elm architecture, and life's great. So
yeah, agreed.
So okay, you have been working at Real Folk, and you've been working on this project Qoda. Is that a project that it's not a contract, right? This is a product that you all are building as a product yourselves, right?
Yes, exactly. So so I worked for Real Folk for about a year, and then we got an opportunity to do something with the blockchain. My CEO and CTO, they have a background in finance, and so they spun off this separate company to actually do Qoda. So it's not necessarily Real Folk doing it, but yeah.
Yeah, the same folks,
but
just not the Real Folk folks. Yeah. Awesome. Yes, and so you recently created this Elm Natural package in Elm. Would you tell us about what problems that solve for you?
Sure. Yeah, so as I continue to use Elm, new challenges come up. So one of the things that we use a lot at on the Qoda project is the Bigint library, which was written by Corey Ditch, I believe. And so we use that extensively. And I just wanted to understand better how that worked. I always had a fascination with big numbers and like how to implement them on the computer and stuff like that. So I decided, as a little side project, I would I would try to recreate that library from the ground up. I separated the big number implementation into Elm Natural, Elm Integer, and Elm Rational. And so Elm Natural is like the first version of this thing that just represents natural numbers using an arbitrary amount of memory, whatever it's needed to work with these numbers. And it was just a side project to see how to structure such a code base and how to implement the algorithms, because I like working with algorithms. And yeah, it's just a fun side project. There's no major goal for it as yet, but it could be used as the foundation of more libraries that I can build on for Ethereum based blockchains. So
Okay.
that's the possibility, but it's not necessarily a goal. It's just for
Mm.
fun.
So your Elm Natural project is not a tool that you're planning on necessarily using in production. It's about understanding how these numbers work. And do you recommend using Big Int still for this, or do you think that maybe if folks have a subset of problems that they should use your package, or what are your recommendations there?
Sure. So Elm natural just represents the natural number. So you can represent any natural number from 0 to however large you want, once the memory is able to represent it. But the bigint library represents integers basically. And so if you're working on a project where you need to represent negative numbers, which is probably the majority of the case, then Elm natural might not be for you. But there's Elm integer that might be coming along, where maybe when I release that project, then I'd say that's a project that many people might be able to use.
Okay, excellent. So yeah, we'll look forward to hearing about that. And so I have one thing that you had posted on Discourse, and I wanted to share it with you. It was about this article by Cal Newport on Beethoven and the gifts of silence. And this is you quoting Cal Newport. So Cal Newport says, "In our current techno-cultural moment, we're constantly connected to a humming online hive mind of takes and urgency and quantified influence. Sometimes it seems there's long-term advantage in removing society's soundtrack from your ears, even if in the moment the absence is acute. As Beethoven so vividly demonstrates, you can't really hear yourself until you're able to turn down the volume on everyone else." And then, quoting you after this, says, "Consider how different Elm would be if Evan didn't intentionally work the way he does." And that's it. I thought that was a really beautiful thing that you shared there. So, did you have any comments about that, or not?
Sure, I can comment on it. Well, first of all, it's a beautiful quote, and I appreciate the ideas that Cal Newport shares. I like he's a author and an academic. As a writer, he writes tons of books on productivity and on the impact of technology on society. But his books have really helped me shape my career and move in the direction that I'm currently moving. So, for example, he famously wrote Deep Work and Digital Minimalism, and so it helped me to reduce the noise from social media and Slack, and really focus on what I wanted to do. And it's one of the reasons I'm able to work on so many different projects and really focus my attention and become as productive uh, that I've become.
Yeah, I think that's great. When I have read about, I haven't read all of those books, but I've read bits of them and kind of gathered knowledge about Cal Newport's work. And whenever I see that the title, digital minimalism, I think about Evan. And
Hmm.
so I thought it was great that you made that connection as well, and shared that. So is there? I think really I don't have any other questions written out for you. Is there anything else that you wanted to share before we get to picks?
Uh, no, I think we can move ahead to picks. There's nothing else that I think I need to share.
Okay. All right. Well, what picks do you have for us?
Sure. So the first one was SICP. So as I mentioned, SICP was my introduction to functional programming. Though it can be a complicated read, I think it is a necessary read, and it would help you a lot with functional programming. And if that book is too complicated, then there was a book called How to Design Programs that goes through the same concepts as SICP, but the pedagogy is much different, and so it uses better examples to explain those concepts. The other pick I had was actually Cal Newport and his books. Like it really helped me, and you can read them and gain some insight from it. So some of those books include So Good They Can't Ignore You, Deep Work, Digital Minimalism, and A World Without Email. I think A World Without Email like really represents the way everyone works. And so if you read that book, you'd get a better understanding of how he works and why he works that way. At least that's my opinion. And like I've been really into programming languages recently, and the book Essentials of Programming Languages has helped me to understand how to implement various programming features and also translate those ideas into my day-to-day job. So it talks about like continuations and continuation pattern style and tail recursion and stuff like that. And so I think it can really add value to especially functional programmers. So those would be my three picks.
Excellent. Yeah. So this Essentials of Programming Languages, who's the author of that?
Dan Friedman and Mitch Wand.
All right. So I'll add some links to these in the show notes. Did you have any other picks for us?
No, that's it.
Okay. So I just have one pick today, and that is since we're talking about ports, I thought the former host of Elm Town, the original host, Murphy Randall, gave a talk at ElmConf 2017, the importance of ports. I'll add a link to that as well, but I thought that really kind of fits into our conversation about ports there. And that's it. Well, thanks, Dwayne, for your time, for coming to Elm Town. Until next time, goodbye.
Thanks, Jared. Thanks for having me.